Okay, so looking at 20, it says initially a pendulum swings through an arc of 2 feet. On each successive swing, the length of the arc is zero point 0.9 of the previous arc. What is the length of the arc of the 10th swing? After the 15th swing, what total length will the pendulum have swung? And then when it stops, what's the total length the pendulum will have swung? So what we have to do here first is come up with that formula for our nth term. And so what we're going to do here is the first term is 2 feet. And so we're going to have a sub n equals 2 feet times our ratio, which is going to be that point 0.9, and then raise to the power of n minus 1. So when you plug in 1, your ratio value turns into a 1 because zero point 0.9 raised to the 0 power would turn into 1. 1 times 2 is 2, and that's our first initial swing. So then let's see. Part A says find the length of the 10th swing. So we just have to figure out A sub 10. So we're going to figure out the 10th term here. So let's see. 2 times zero point 0.9 raised to, oops, let me see. Sometimes this pen, there we go, can be a little finicky. All right, so let's see. The 10. So 10 take away 1 is 9. And so I need to put that in my calculator. So you do have to be a little careful when we put these in our calculator. And so let me turn mine on. All right, so let's see. 2 parentheses zero point 0.9 raised to the power of 9. And so we get about 0.77 and then rounded to 5. And I believe that's what was in the key. So 0.775. Then it wants us to figure out the sum total of the first 15 swings, and that's where this formula is going to come in. And so we have our R value. This, as mentioned, this is our R value here. That's our A sub 1. And so we have everything we need. So we'll just go ahead and plug it in. And once again, you just have to be really careful for when we plug it in the calculator, though. Mine's kind of an older one. Some of the newer ones, the interfaces are a little bit nicer, but you do have to be careful. So let's see, we're looking for the sum of the first 15 terms. And so we're going to have 2 parentheses. And so the way I'm going to have to put this in the calculator is I'm going to have to put in 1 minus zero point 0.9 raised to the power of 15. Okay, and then I got to close that parentheses, divided by, open a new parentheses, and do just 1 minus 0.9, close that parentheses, and then close that parentheses. And so depending on if you're using kind of a newer calculator, it might be a little bit easier for you to input, but for me, I'm basically going to have to type it exactly how I wrote it. It's not going to look exactly like that in the calculator, but that's the order that I'm going to punch my keys. So 2, open up my main parentheses, and then I have to open up another parentheses for my numerator. And then I'm going to have 1 take away zero point 0.9 raised to the power of 15. And then I'm closing that parentheses of my numerator right there. Then I'm going to divide, and then I have to open up a new parentheses. And then let's see, we're going to have 1 take away zero point 0.9, close that parentheses, and then close the main parentheses right here, the outside that's holding all of this, the fraction. And then I'll go ahead and press enter. And I get about 15.882. And once again, I think that should match what the key has. So let's see, 15.882. Okay, and then actually the last one is probably going to be the easiest one. That formula is pretty simple. If you want to figure out the sum of all terms, what we're going to do here is we're going to plug in the first term, which is 2, and divide it by 1 minus 0.9. Now, once again, I got to put that denominator in parentheses or else the calculator will not read that properly. So I got to be a little careful there. And it should just come out to 2, but let me kind of show you in the calculator just to make sure we got this. So 2 divided by, so see, if I don't open a parentheses, what happens is my calculator will only divide by 1. and then it'll end up subtracting my answer by 0.9, and so I don't want to do that. So minus 0.9, all in parentheses there, and then there we go. And so we get 20. And there we go. Okay, the next problem's pretty similar. It is a little trickier though. So let's go ahead and take a look at that. So right here it says a ball is dropped from a height of 100 feet. Each time it strikes the ground, it bounces up 0.8 of the previous height. What is the height of the ball? What height will the ball bounce up to after it strikes the ground for the third time? What's the total distance does the ball travel before it stops bouncing? Okay, so this one's a little tricky because the formula we're going to come up with is going to measure the bounce height. And so the ball is dropped from 100 feet and it bounces 0.8. So that means um, it would bounce up to 80 feet. And so what we're going to have to do here is a sub n is going to equal, because remember, that's your first term right there. That's what a sub 1 is. A sub 1 is 80 feet, right? Because you're going to drop it from 100 feet. It's going to bounce up 0.8 from that distance. And then we'll multiply that by our ratio value right there. And then we're going to have n minus 1, so that when you do plug in 1, you will get 80 for your first term. And so then let's see, part A says, what height will the ball bounce up after it strikes the ground for the third time? And so we'll find a sub 3. So let's see, we're going to have 80 times 0.8 raised to the power of 2 once I subtract the 1 from it. And we'll go ahead and put this in the calculator here. So let's see, 80 parentheses 0.8 raised to the power of 2. And so we get about 51.2. Okay, so that wasn't bad. Now part B, it's not that it's really hard. You just kind of have to really think about what's taking place. So on part B, this is what's going to happen. We're going to drop the ball 100 feet. Then it's going to bounce up 80 feet. Now this is the part that you have to think about. And this is where a lot of students end up sending me emails kind of getting a little confused about this. Because what happens is it bounces up 80 feet. And now we're looking for the total distance the ball travels, not just dropping and bouncing up. You got to do each part of it. You got to do the drop, the bounce up, and then the drop again. So it's going to drop 80 feet again, and then it's going to go up around 60 or 70, something like that, and then it's going to go back down, and so on. Now, what we're going to do here is we are going to figure out how high it bounces in total, and so that formula is going to be the first term, which is 80, divided by 1 minus our ratio value, which is 0.8. So that's going to give us all the rebound effect, the distance from it bouncing after it hits the ground. And so let's go ahead and figure that out, and then we can kind of talk about what's next. So let's see, we're going to do 80 divided by parentheses 1 minus 1 minus 0.8. Close that parentheses. Got to put that in parentheses right there. So I get 400. Okay, so that's all the distance that it bounces up. But it wants the total distance that the ball travels. So what goes up must come down, right? So it's going to bounce up a total of 400 feet, and that's also going to be dropping a total of 400 feet. So we're actually looking at 800, but that's not quite it yet, though, because we also got to remember the initial drop. I didn't include that because I had all the bounces. It bounces 80 feet. It bounces, whatever, so on and so on. And that's where that 400 comes from. And then I doubled it because it bounces up, comes back down, bounces up, comes back down. And then I need to add that last 100 there from the initial drop distance. And that's where the 900 comes from. All right. Well, I hope that kind of clarifies that. And if you have any other questions, just let me know.